We, the students of Sardar Patel Institute of Technology, are at the Bhavans Lake, which is a lake in our campus itself. For the problem stated earlier in the video, we have made a device which is named as W.A.T.E.R, named as Water Analysis Testing Estimation Remotely. Now this device consists of two parts. One is the transmitting device, as you can see here, and one is a receiving device which can be placed at a receiving station, which is basically a graphical user interface. Now this transmitting device consists of 5 sensors. Starting from left, here it is conductivity sensor, pH sensor, ORP sensor, and dissolved oxygen and turbidity. Whereas the receiver side consists of a GUI which will display the parameters from the transmitting device. Now let us consider why we have selected these 5 parameters. Starting from conductivity. Conductivity gives the conductivity of the water and thus stating what is the metal content in the water, since metal conducts electricity. Then we have pH sensor. pH is a very important sensor since it shows that whether the water is acidic or basic. Then we'll go for ORP sensor. ORP gives the antibacterial strength of the water as well as the bacteria content in the water. And then last but not the least, the dissolved oxygen sensor. Dissolved oxygen sensor gives the oxygen content in the water, since water supports aquatic life. Then the turbidity sensor. Turbidity sensor gives the amount of solid impurities in the water. Now we are choosing these 5 parameters to grade the water. Thank you. The hardware of our device consists of 2 parts. One is the stirring mechanism and another one is the rotating platform. Let us see the hardware structure of our device. The hardware structure of the device consists of 5 sensors explained before. These 5 sensors, they are calibrated using the calibrating solutions placed here. The output of these sensors, they are fed to the signal conditioning block. Further, it is given to the central processing unit, and these parameters, they are sent using W.A.T.E.R model to the receiving end. Let us see the circuit in detail. The signal conditioning circuit are of 2 types. The first type of signal conditioning circuit consists of 3 stages. The first stage consists of a low pass filter made using LF411CD IC, which is provided to us by Texas Instruments. The cutoff frequency of this filter is 50 Hz. The second IC is LM741 provided to us by Texas Instruments. We have made a low pass filter using this IC of cutoff frequency 60 Hz, and the output of this IC is fed to INA128, which is an instrumentation amplifier provided to us by Texas Instruments. We have used a amplifier in our circuit because the output voltages of the sensors are very low. The second type of signal conditioning unit is a voltage divider. We have used a voltage divider for a turbidity sensor because the output of turbidity sensor was very high. The second type of voltage divider which we have used is because the output of conductivity sensor and temperature sensor was in resistance. All these values of signal conditioning unit, they are fed to the MSP430 launch pad, which processes it and further sends it to the GPRS module. The GPRS module which we have used is SIM900A. It transmits the parameters to the receiving end using the transmission control protocol. All the circuit, they are powered using 4 lithium-ion batteries placed here. Now we can check about the stirring mechanism. The stirring mechanism consists of one motor to which this rotating platform will be attached. Here you can see the LM317 IC, which is a voltage regulator IC. We have used this IC to power the motor. All these designs and simulations of these circuits, they are done using TINA software and W.A.T.E.R. Thank you.
The screen seen in front of you is the GUI for W.A.T.E.R. It has been designed using LabVIEW software. Let's select the type of parameter. We select quality parameters. The device used for testing purposes has been configured as server, and this computer has been configured as client. The input data has been received as string, which is converted to numerical format and graded according to CPCB standards. The relevant comments are present on the right hand side. Not only that, but also the data has been stored in .lvm format and can be viewed using Notepad.
As of now, you can see the on-field real-time testing of our device. Today we are in the Bhavan's Lake and we are going to test the water quality of Bhavan's Lake. On the device you can see we have a stirring mechanism. We have connected a stirring mechanism to our device because during sensor calibration we found that stirring gives more accurate readings. On the left side of the screen you can see the real-time on-screen capture of the graphical user interface, which currently our friend sitting at the main building of Sardar Patel Institute of Technology is seeing. You can see the data or the parameters sent by the GPRS module on the transmitter coming one by one on the graphical user interface. The four sensors which you can see at the bottom will be dipped into the water, whereas for the turbidity sensor we have already collected a sample and placed into it. Now let's continue with the demo.
The interactive screen seen in front of you is the GUI for water analysis testing estimation remotely. There are two types of parameters, quality parameters and biological parameters. We select on the quality parameters, which brings us to another screen. Here there are 6 quality parameters that are listed. Each is going to show its output. The first one being oxidation reduction potential sensor, and we get the output as 200.3 millivolt. The next is pH, which gives us a value of 5.6. The dissolved oxygen sensor gives us an output of 7.1 milligram per liter. The conductivity sensor gives us an output of 800 microsiemens. The temperature of the lake water is 25.8 degrees centigrade. The turbidity of the water present at the lake is 110.23 NTU.
Further improvisation for a device will include addition of more number of sensors. These include addition of chlorine sensor, nitrate sensor and COD sensors. COD sensors are used in wastewater industries and thereby increasing the acceptability of our product. Next is uploading data on Google Maps. People who travel from place to place will find this feature useful. Next is use of solar energy. Currently our device is being powered by batteries. Use of solar energy will eliminate this problem.